In this example, we'll show how to calculate the tension for these belts. If you look your car, many things are connected by belts, so the power is actually transferred by belt to the alternator, water pump, power steering pump, cooling pump. So there are a bunch of things are run by this. So the amount of torque needed to power those small equipments, they're actually run by these belts. So we'll show you how to do that calculation. So let's take one of these pulley, for example. Let's say that's a 12-inch pulley, and then again belt tension. It doesn't matter which side you assume positive, or they're all tension. There is no push. One side is larger than the other side. Assume that, let's say this is a power steering pump. It takes definitely not this high, but let's say it takes 1,000 pound-inches of torque to run this pump. Now this 1,000 pound-inches torque, we said that's positive. So with respect to the center O, that's going to be in this direction. So we said is 1,000 pounds, so that's our positive direction. So then this TL side would be larger, so it's pulling this way. So this would be the large tension side, this would be the smaller tension side. Now assume that they're 12-inch pulley. None of those are 12-inch pulley, just for the sake of easy calculation. So it's going to be 6 inches from each side. So if you take moment with respect to the center, MO, which is given 1,000 pound-inches, not 0, so it is transferring 1,000 pound-inches. So if you do TL, we'll do a counterclockwise moment with respect to O times 6, minus TS, we'll do clockwise with respect to O, so that's 6 also away from O, and then everything summed to now 1,000 pound-inches. If you do the calculation for, now we can do then TL minus TS is equal to, I found that 167 pound, the difference between tension of these two sides. We have another equation that we can use. TL by TS is E to the power the friction coefficient times the angle of wrap. Assume the angle of wrap here is 180 degree, which is pi 3.14. So if you use this TL by TS, E to the power 0.2, say friction coefficient times the 3.14, so I found that 1.87. So TL by TS. So we can use this equation here. We can plug the value for TL is 1.87 TS. So then 1.87 TS minus TS is equal to 167. So TS I found 190, and then TL, the large size tension, I found 357 pounds.